We're live.
Great. Hi, everybody. Welcome to Wikimedia Tech Talks. Wikimedia Tech Talks is a monthly series that showcases speakers from the Wikimedia technical community. Please check out the Tech Talks page on MediaWiki for more information, or to view past talks, or to propose a talk of your own. And I'll put a link in the description to the YouTube page so that you can follow that. Today we have Andrew Otto, a staff site reliability engineer on the analytics team. Andrew will be talking about Wikimedia's event platform. Andrew will give his talk, and after we'll take questions from the audience. You can submit questions through the live YouTube stream or through Wikimedia Office IRC, and I'll share the questions with him. So without further ado, I'll hand it over to Andrew. Thanks, Andrew.
Great. Hi, everyone. Yeah, I'm Andrew Otto. I've been at Wikimedia for about 8.5 years, and almost that whole time on the analytics engineering team, doing a lot of big data infrastructure with Hadoop and Kafka. Over the past few years, I've been focusing a lot on our event ingestion and event streaming systems. And today I'm going to talk about some stuff we've been working on over the past couple years that we call the Modern Event Data Platform, or just Event Platform for short. So I want to start off with an old slide. As I was putting this presentation together, I was looking through an old tech talk that I gave from 2 years ago that contained this following slide. This is a quote from some documentation, and it says that in the future, we'd like to modify event logging analytics, which was our analytics instrumentation event data capture system, so that it looks a little bit more like EventBus, which was our production event data capture system. So we wanted to unify those two systems, and today we have Event Platform. So in addition to unifying just two systems in production, we also wanted to build something that enabled software engineers and developers and system architects to build event-driven software. I won't go into too much about what I mean by event-driven software here. There's various types. I'm mostly partial to event sourcing. I won't go into that too much. There's a talk coming up on October 7th by Ben Stopford for Wikimedia that hopefully he'll talk a little bit more about that. But first, what I will go into is what is an event? What do I mean when I say like event-driven software? What does event there mean? In general, it's pretty simple. Events are just a way of modeling data. We model data as something that happens at a specific time. We can think of like an edit in Wikipedia being saved at 9 a.m. And we might model that as including the fact that an edit was saved at 9 a.m., but also a bunch of metadata around it, the content, the user who made it, anything else that we might need to capture when we're modeling that change. Or it could be that Luca made coffee at 2 p.m. Whatever it is, it doesn't matter. It's just the time component is very important there. We're going to use this series of events to capture a history of changes. Events are facts. I would argue that modeling data as events is closer to reality than modeling data as state. When I say modeling as events, I mean like an event log, a history of changes. Things happen and then state changes. I put a little asterisk here because one of my teammates was like, do you really want to say this? Are you sure this is what you mean? And I'm going to stand by it. When I say reality, I'm thinking of like in the sort of like special relativistic sense, like reality being a series of causally connected events that happen at a point in space in a moment in time. So yeah, I think that modeling data as events is closer to reality, but that just because I think it's closer to reality doesn't mean that I think that it's necessarily better. We of course need to be careful about the choices that we make when we do data modeling and make sure that they match the use cases that we're trying to implement solutions for. Anyway, events are history. I think that one of MediaWiki's strengths is that the revision table is an event history store. Every revision is captured as a change and is saved for all time. We can always go back and rewind the events, look at the state of a page as it was 5 years ago. We can replay events to get the current state of the page. I think that's been really powerful in helping Wikipedia be successful in what it does. But not all of MediaWiki data has history like revisions do. There's a lot of pieces of information that we're not capturing. Link changes for a page, for example. Technically, I guess that's captured inside of the wiki text of a page, but there's no explicit event history about the link changes. Those have to be rebuilt. User renames, user preference changes. We could think of a bunch of things that aren't stored inside of MediaWiki as events. As a quick aside, the analytics engineering team, if you haven't heard of it, has a data set that they call MediaWiki history, which is a reconstructed event view of all of the history of MediaWiki. That has been reconstructed from snapshots of the MySQL database using the logging table that is there. So some of this data is captured inside of a log, but it's not captured, it's not emitted or modeled as an event, and it's not saved as a history of those events. So it's there, but it's hard to extract. Anyway, that's just a quick aside. I think MediaWiki history is really amazing. And if you haven't heard of that, you should look it up because it's very cool. Also, unfortunately, the revision events for the data that we do have an event model and a history of, those are locked inside of MediaWiki MySQL, which is particularly relevant when we talk about trying to use events to decouple services. If these events that we're trying to emit to model state changes or model data as things happen, if those are consumable by anyone, they allow for building decoupled services. With MediaWiki right now, the main ways to get access to the event data that we have in the revision table is either through the API or by building something onto MediaWiki, maybe something in MediaWiki core or an extension that can access the actual database itself, or to grab a snapshot of the event history in the MediaWiki dumps. There's no default way to build a decoupled service that does not, that is not coupled to MediaWiki itself. But if events are consumable, they allow us to do this. So we could use them to update an Elasticsearch index with the current state of a page. We just need to consume these events, do what we need to do. We don't have to reach out to a centralized database in order to use the data. And especially events plus a message bus like Kafka can really help us out here. So I think this is one of the reasons why people are talking a lot about event-driven architectures and designs these days, is because Kafka has enabled building these type of systems at scale. By putting events into Kafka, we're able to do what we were saying in the last slide. If events are consumable, Kafka makes them consumable. We can be more flexible to unforeseen use cases in the future. We can build services that don't need to interact or coordinate with the source producers of data. And I think that's really important. That empowers teams to make incremental architectural changes. There isn't this large collaboration that needs to happen. For example, with MediaWiki, you might be able to build new services that do really important things without having to be involved in MediaWiki if we do event architectures well. The data, by doing this, the data is exported by default. It's liberated, it's out there for other people to use. An important gotcha, though, is that if we don't do that carefully, we can run into a lot of problems, a lot of compatibility problems. If we're going to liberate data, we need to have a contract that ensures that producers of data can't change the format of the data in such a way that might break consumers. And that contract is enforced by event schemas. This is pretty similar to if you're thinking of like a microservices API type use case. This is the same as having a contract for an API spec. You can't change the API because there's lots of people that use that API and you don't want to break them. In the event world, we enforce those types of contracts with event schemas. I'm gonna launch into talking about schemas a bit and how we do schemas with Event Platform, but I wanted to add this slide that I note that event-driven architectures can be pretty complex. I'm doing a lot of evangelizing here for them because I think they're cool. I think that they could be very useful, but I do recognize that they are complicated. When you start having to think of streams of events and copies of that data all over the place, you can get into problems with consistency and eventual consistency. Things become more asynchronous, which is kind of difficult to reason about. State gets distributed in many places, which is always difficult to reason about. But I think that in a lot of cases, the flexibility can outweigh some of these complexities, but still we need to be really careful and make sure that we're choosing the right architectures for the right use cases and for the right reasons. So I'm really into all these events and event-driven designs and architectures, and I think they're really cool, but you know, we gotta use the right paradigms for the right solutions. Just a little caveat there before we go into schemas. So why do we need schemas? If you own both the producer and consumer of data, you might not. You can, if you own all of the usages of a piece of data, then you can make changes to that data format and roll out the migration to the consumers or producers in whatever way that makes sense. You can make a breaking change, upgrade the consumer first, maybe then upgrade the producer. However it happens, you have control over that system. So you might not need schemas in that case. But in our case, we're trying to liberate the data. The data is going to be everywhere. So we need to enforce this contract. We need to make sure that we don't break consumers. So we use them for ensuring that events satisfy a contract. And we also use them for solving data integration problems. When we're consuming those events, not only do we want to be sure that they're going to be compatible with what we've seen before, and they're not going to break our code, but we'd like to be able to ingest those events into different systems, perhaps into different data stores. And if you know, having a schema gives you a way to automate that ingestion because you know the structure of the data that you're going to import. So having the schema will solve these problems. This is sometimes called, in the analytics world, extract, transform, load. I just call it data integration. It allows you to automate data integration problems, having the schemas. So at Wikimedia, we use JSON, and JSON schema is a natural choice for schemas of JSON. But in the Kafka event streaming ecosystem, there's not a lot of tooling to support usage of JSON. Most people, or most of the systems, the ecosystem has evolved around using Avro, which is a binary serialization format. And there is a tool from Confluent, which is a company started by the founders of Apache Kafka, called the Kafka Schema Registry. That works with Avro. Recently, it's had some JSON schema support added, but that's only very recently. Those things together do two really important things that we would want in an event platform, and those are distributed schema lookup and schema evolution, also known as schema versioning. Schema evolution is what enables us to be sure that we can be backwards compatible with changes. And the distributed schema lookup is so that we can look up schemas for validation purposes and also for the data integration, solving the data integration problems that I mentioned before. But JSON doesn't have these things. There's nothing really around that does this. So we had to implement this ourselves. So, right, like I just said, we need to always know the schema of the event. This event data could live anywhere. Any consumer might need the schema for some reason. We're going to have events that exist in, I don't know, in Hadoop or some data store from like 6 years ago that we need to be able to look up the schemas for. So how do we solve that? When we were thinking about this, we were looking at JSON schema, and we noticed that it already has a convention for pretty much doing exactly what we want. JSON schema has a $schema field, which it uses to look up what it calls the meta schema. This is the JSON schema specification schema. JSON schema implementations use this it's set to a URL of a JSON schema specification, and they use that to look up that JSON schema version specification and validate that whatever JSON schema that an author is writing is usable or it matches that JSON schema version spec. That's pretty much exactly what we want to do with event data. This schema is really just a URL that is pointing at the JSON schema of the current JSON document. And that's what we want to do as well. We have an event data, and we need to map from that data to a schema. So we decided to use $schema for this. Usually $schema is set to a fully qualified URL of a JSON schema spec when you're writing a JSON schema, but we want to be decentralized. We don't want to have to couple to like a fully qualified domain name website. We want our schema data to be possibly even used by third parties, people who aren't at the Wikimedia Foundation. And we'd also like this system to work for people who aren't using MediaWiki or MediaWiki data as well. So we want to be decentralized. We don't want to tie to a specific fully qualified website. So what we do is we set $schema in our event data to a versioned path URI. I'll talk a little bit more about that version in a bit, but instead of using a fully qualified URI, we just use the path part. This is an example of MediaWiki revision create version 1. This is a real schema URI in production. We then rely on software to prefix those URIs when it needs to look up a schema with a path, with a fully qualified path. So we keep our schemas in Git. This means that a production service that needs to look up a schema might just make sure that it has the Git repository cloned and then prefix the incoming schema URIs with a path in the local file system. Or if we want to be more dynamic more dynamic, we can prefix it with a remote HTTP location. So this is an actual URL to our remote schema repository. What's nice about keeping all the schemas in Git and having these paths is that the paths are consistent everywhere, independent of where they're hosted. We just have to prefix them. And that's what allows us to use the URIs in the event data, and especially those URIs that are going to live in event data forever. Right, forever. All versions of all schemas must be lookupable forever. We might have an event from 10 years ago that has some old schema version, and we still want to be able to get that event. That schema. Additionally, we need to make sure that every new version of a schema is 100% backwards compatible with the old one. We need this especially for the data integration problem. When we're ingesting events into, let's say, a Hive table or a MySQL table or something like that, we need to be able to stick the old events in there, and we need to be able to stick the new events in there. And they still should all work inside that one table. So we need them to be backwards compatible with each other. To do all these things, these static URIs, managing those, ensuring backwards compatibility, we built a tool and library called JSON Schema Tools. It is really just a schema repository manager. It's meant to manage JSON schemas inside of a Git repository. It allows you to only have to ever edit a single file, but then it will materialize these static version files alongside of the file. I'm going to do a demo in a minute where I explain this, but you can see here that the file that we might be working with is called MediaWiki revision create current.yaml, and it is going to materialize whatever version is inside that file to a static file. We then commit those static files to Git and host them via HTTP, or someone can clone them like I talked about before. By having all these static version files, that gives us the consistent file-based path URIs. We stick those in the events at the $schema. So that's very nice. JSON Schema Tools also has a bunch of tests that we use to enforce that the schema repository has a good structure, a bunch of conventions that we might want to enforce that our schemas have, but most importantly, the backwards compatibility. We ensure that whenever someone changes the schema and makes a new version, it's compatible with the previous one. And that's all done just using regular unit tests. These things together, the versioning and the backwards compatibility enforcement, satisfies our second requirement that we were missing from JSON and JSON schemas, schema evolution. So now we've got the ability to look up event schemas in a distributed, decentralized way, and we're sure that those schemas are immutable and backwards compatible for all time. So that schema's there. I'm going to do a quick little JSON Schema Tools demo. So I think you can still see my screen here. What I have open in my editor here is our primary event schema repository. So these are schemas that are actually being used by production event data. And I'm going to first look at MediaWiki revision create over here in the current.yaml file. So this is the only file that a developer should ever need to edit. They shouldn't have to edit any of the other actual version files. You can see here, I've got a title. This title actually has to match the path in the schema repository. It will be used for some things I'll show later. It has an ID. This is a JSON schema keyword that is a unique ID to the schema. It's also what is going to be used for the $schema URI in the events themselves. So this contains the version and the path URI that we want to identify this schema with. You can see here's the JSON schema's use of $schema. It's pointing at a draft 7 schema spec. So this is inside the JSON schema document. That's all like metadata data about the schema itself. Then here we have the schema properties of revision create. The only thing I'll note here is this ref. This is a JSON ref pointer. It's the JSON feature. JSON parsers can will know how to look up URIs and include the content at those URIs in this schema here. So we're using this to include a fragment schema, so we don't have to copy and paste a bunch of common fields that we might want in a bunch of revision related schemas. Yeah, that's revision create. That's kind of the basic of how a schema document will look. Let's go through a little exercise where we want to create a new schema. We don't yet have a user create event, but let's say for some example, we want to start emitting event data about user account creations in MediaWiki. So we're going to make a new schema called MediaWiki user create. We're going to make version 1.0.0. So we've set its ID to the path and of the schema and the version. And then we're going to declare some properties. I'm reffing out some common MediaWiki properties here. And these are the schema specific properties. I'm only adding 2, user ID and user text, both of which are required. So this is our current.yaml file. Let's use JSON schema tools to materialize it. This schema repository is actually configured with a get pre-commit hook. So if you were doing this in development, you might just git add current.yaml and commit, and everything would be materialized. But for the purposes of the demo, I'm just going to run the command line interface directly. So I'm running here JSON schema tools materialize, and then the path to the user create current.yaml file. So I'm going to go ahead and run that. And I hope my font's not too small here. I'm going to try to make it so that everything fits on one line. That's almost there. Good enough. Hopefully you can all still see that. Right, so it's telling us what it did. So you can see here, it found the ID, MediaWiki user create 1.0.0. It dereferenced it, so it's taking this ref pointer that we've done and turning it into, as you'll see when it materializes it, it makes it a static version of this. It's dereferenced it and included the content statically. It's created these static version files, have a YAML version, a JSON version. We've created an extensionless one, symlink to the YAML version. This is actually the one that we'll use for the URLs, so we don't have to think about the extension so much. And then we also created a few symlinks latest that point to the latest schema version, so that if all we need is really the latest schema, we're not trying to find a specific version, we can easily request that. And if we look at user create 1.0.0, we can see we have what we had before, but also here's the dereferenced common pieces. We can see we've declared a $schema property. So every event needs to have this field, and that's when an event data comes in, it needs to have this set to the ID of this schema, which in our case is going to be user create 1.0.0. Then there's a bunch of fields that got included from the MediaWiki comment, but at the bottom here you can see we have our user ID and user text, which are our properties that we declared in current.yaml. Cool. Let's make a change. Let's go back to current.yaml here. Let's say we've been using this schema for a little while, and we want to make a new version and add an email field. So let's make a new version. Let's bump it to 1.1.0. And we'll add a new field called user email, and its type is going to be string. I should probably also add a description, but for the demo, I won't bother. OK, so we've added user email, bumped the version to 1.1.0. Let's run the exact same command we ran before and materialize user create current.yaml. Same thing as before, except for this time you can see it's materializing 1.1.0. The symlink latest updated to 1.1.0. If we look in our files, it's exactly as it was before with a new ID and our user email field. Cool. Now let's run the JSON schema tools tests. So this repository is set up so I can just run npm test. It's going to run a ton of tests. It does some things like ensuring a bunch of conventions that we want to force, snake case, etc. But more interestingly, we have here MediaWiki user create major version 1, 1.1.0 must be compatible with 1.1, and it passed. So that's great. So let's do something we're not supposed to do. Let's try to make a backwards incompatible change. We'll just go ahead and bump the version to 1.2, and I'll change the type of user email to an integer. This should not be allowed. So we've got to materialize just like we did before. We've materialized version 1.2. So now when we run the tests, it's going to check that 1.2 is compatible with 1.1, and it's going to check that 1.1 is compatible with 1.0, etc. Let's run the tests here. Same stuff. We've got user create here. Fine, 1.1.0 is compatible with 1.0, but 1.2 is not compatible with 1.1. And it tells us why. User email type expected to be a string, but was an integer. Cool, that's what we want. We want to enforce backwards compatibility between the versions. So now that we've done this, you can see we've got all of the version files, and they're going to exist in, they should exist in the Git repository. We check them in and commit them and review them and merge them, and they'd exist there forever. They'd be deployed to a remote schema repository. They'd be and loadable from there, or you could clone the Git repository for your production service or your development environment and use the schemas there. Great, go back to the presentation here. So that's the demo. Moving on, so we've got schemas, and we've got a good system for looking them up in a decentralized way, and we know that they're going to be backwards compatible with each other. How do we produce events? In Event Platform, we do that with something called EventGate. EventGate is actually pretty simple. It's just an HTTP event intake service. It's a generic service. It's not WMF specific, but by default, it knows how to do exactly what we were talking about. Use $schema URIs to look up event schemas, validate incoming event data, and then for us, produce it to Kafka. Right, but it's non-WMF specific. We did that on purpose. Just like with the JSON schema world not having a lot of, the ecosystem not having a lot of tooling to use JSON schema and JSON in Kafka. That's true for HTTP produce proxies as well. Confluent does have something called the Kafka REST HTTP proxy. It does now recently have some JSON schema support, but that's only a recent change, and it's also not an open source license, so we can't use it. So we thought we would implement something that possibly other people outside of the foundation could use. To use it in a generic way, all you have to do is implement validate and produce for these functions and make them do what you need them to do. But there are default implementations to do what we do as well. We have some specific implementations that do some things like setting defaults. Like we look at some incoming HTTP headers and set some default values in the events if they're in the schemas. And all those Wikimedia specific functions are in a different repository called EventGate Wikimedia. I'd like to talk also about event stream config. Unlike EventGate, this is very Wikimedia specific. I don't think that anyone would even use this outside of Wikimedia production, so probably not even for MediaWiki third parties. This wasn't originally part of Event Platform as we were planning it, but as we did interviews with product owners and we're trying to collect user stories for the different components, it became clear that a big missing feature that they were missing from the old event logging analytics system was the ability to more dynamically control producer behavior, mostly, and they were mostly concerned with being able to dynamically change producer sampling rates. So we decided to build something for them to allow them to do this. And along the way, it actually became useful for us, for our backend use cases as well. I won't go through all of these. There's various things that we use event stream config for now. There's probably some things we'll use it that we don't know we're going to use it for yet. But for example, in the backend, EventGate uses it to make sure that only events of a single schema type are allowed in the stream. So we want to make sure that we don't accidentally send revision create events to, say, the user create stream. Yeah, and a bunch of other things here that we use it for. Event stream config was implemented as a MediaWiki extension. It's just a PHP and HTTP API to get settings for a stream. And those stream configuration settings are stored inside of a MediaWiki global called WG event streams. So this is actually an example of a production stream. This is revision score. And this is kind of the minimal stream configuration that we need. We need to know the stream name. That will eventually get mapped to a Kafka topic or multiple Kafka topics, but that's the logical name of the stream. And the schema title, that's how we ensure that events of only MediaWiki revision score are allowed in this MediaWiki.revision score stream. And the destination event service is saying that EventGate main is we have several EventGate clusters or services in deployment for different purposes. And this is saying this one called EventGate main is the one that's allowed to produce these events. Yeah, let me talk about future work. So that's what we've got so far. We've mostly focused on being able to produce valid and consistent event data, but I haven't talked a lot about actually consuming and using that data. There are two big components that we still would like to do that would help consuming the data, and those are event stream connectors and event stream processing. The data is still usable now. We ingest it into Hadoop now. You can write your own Kafka consumer to consume this data and do whatever you need now, but stream connectors and stream processing would help standardize the ways that we do those things. Event stream connectors help abstract getting data into and out of streams. We've already talked a little bit about how we get data into streams. That might be an interesting part for us with connectors. Like, it might be nice to have a generic way to get data out of MySQL by default instead of having to write code to emit events. But at least at first, we're more concerned with how to get data out of streams, mostly out of Kafka, and into other downstream data stores where they can be used by different services. Like MySQL or Hadoop. We'd really like to use Kafka Connect for this. Kafka Connect is part of the Apache Kafka framework. It has a generic implementation for going from Kafka streams into downstream data stores. But unfortunately, a lot of the connector implementations for specific data stores are from Confluent, and once again, are not open source. We have a strong use case in analytics where we want to replace some really old, crufty software that we're using to import streams into HDFS. And we had planned to do it with Kafka Connect HDFS, but because of the open source license issue, we can't. And we're not really sure where we're going to go from here. We might fork some of these connectors from before the license change. We might implement our own. We're exploring other technologies, but unfortunately, the ones we're looking at they're not really generic connectors. They're really focused on Hadoop or some particular technology. So we're not sure what to do. We're a little stuck. So I don't know. We'll think about this more. The other component is event stream processing. Event stream processing frameworks are abstractions for working with streams. They allow you to think of streams as continuous data sets, and they have APIs that allow you to query them, often with SQL. Sometimes you can use special SQL syntax to query these streams. They have a lot of nice interfaces. They allow you to do keyed joins on multiple streams, windowed aggregations, a lot of various things that it'd be a lot of work to implement these things for yourself using just a Kafka consumer. And they do it in a distributed way. So you deploy multiple instances of your application, and you can distribute the load of the streams across many instances. Stream processing gets really interesting when you talk about stateful stream processing. This lets you build and keep redundant distributed states that are updated by streams. So usually these have what are called table APIs that allow you to kind of almost think as if you're working with a static table, but that table is continuously updated by a stream. So the API just kind of like simplifies some of the thought process that you have to do when you're trying to distribute state using streams. These systems often do this are backed by RocksDB, which is a quick, a fast state store, local state store. The state's distributed around different instances using a key. It's pretty cool. You can then query that state using their API, but yeah, I don't know. It's cool. It gets complicated. It's very cool. It would be a really great way to do reliable event sourcing for us, but we don't have a lot of experience with it, so it could be very complicated. The search team is currently looking at Flink to implement an updater, a stateful streaming updater for their Wikidata query service. And it is looking likely that we're probably going to use Flink more and more at Wikimedia if we're trying to do more of this stuff. The other contender is Kafka Streams, which again is part of the Apache Kafka framework. But I think that one of our use cases for a stream processing framework at Wikimedia is going to be ad hoc SQL, so that, for example, the SRE team during a DDoS outage might be able to more easily very quickly write some SQL to try and troubleshoot what's going on with the traffic from a DDoS. And they're not gonna like, write a Java application and deploy it and run it to figure this stuff out. So streaming SQL, I think, is a pretty pretty big requirement for a stream processing system for us. And unfortunately, KSQL, which is the streaming SQL option for Kafka Streams, is again from Confluent and not open source. I think this is kind of like a theme of this talk, it seems. So anyway, yeah, we're likely to use Flink for this at Wikimedia. When it comes to event sourcing and stateful stream processing, definitely come and check out this upcoming tech talk from Ben Stopford. He works at Confluent and has done a lot of really great talks on this stuff. A lot of the event platform ideas are based on blog posts by him from on the Confluent blog, which is also really great. Anyway, that's coming up Wednesday, October 7th. And that's it for me. I thought I would throw up here for the question slide a high-level architecture diagram of event platform components. I know that these slides have been pretty text-heavy, so maybe I thought I would end with an image there. Yeah, that's it. That's event platform as it is today, and what we'd like to do with it in the future. So I think we can open it up for questions.
Awesome. Thanks, Andrew. Yes, let's open it for questions. For folks on the, we'll have room for questions both from the IRC channel and the YouTube stream. For folks on the YouTube stream, just note that we are running maybe a little bit ahead of you on our recording. So if you ask a question, it may be just a second before, a few seconds before we're able to answer that for you. So I'm going to go ahead and check for questions right now. I have a question from IRC. How do you do breaking changes in event schemas, or is that forbidden?
It's kind of forbidden. It is possible to do them, but the problem is that it's possible to do them if you, like, there was a slide where I said, like, if you own the producers and consumers of data, then you can, it probably doesn't matter. You don't need schemas. And that's true for breaking changes as well. If there's lots of consumers out there and you don't control them, breaking changes are really hard. So you might ask the same question about an API spec, like how do you do breaking changes for an API spec? And the answer is generally you don't. Like maybe you can, but if you do, you have to make sure that you announce it really well. You have to say this is no longer going to work, and you have to make sure that anybody who's using that spec, or in our case, that event schema, is like, I don't know, going to be able to get with the program and migrate, or I don't know, decommission and not be used anymore. So it is technically possible to do. It just requires a lot more coordination. So generally, we just say it's not allowed.
Great. And I have a follow-up to that question. It's a little bit longer. I'm going to go ahead and read it to you. Events expose internal implementation details, architecture, etc., but sometimes they are just artifacts and could be a mistake. For example, events in the parsing pipeline shouldn't have been events since it exposes irrelevant internal details, i.e. events were too low level for module contracts. What kind of guidance exists how you decide what events to expose and relevant data?
That's a really good question, and I don't have a good answer for that. That's a data modeling question. I think, I don't know who is best to answer that, but from the little bit of literature that I have read on this subject, just like with APIs, it's you want to expose as little data as, I don't know, it's really hard to say. Like what I want to say is you want to expose as little data as possible, only what you need. But if you're also trying to be flexible to future use cases and you're trying to allow people to do things that you might not have planned yet, it's hard to know where that line is. It's hard to know like what you need or like what people might need in the future. So I can't say that we have a good rule for that in event platform. That's more of a data modeling question. I think it really depends on the use case. Yeah, I'm sorry, I don't have a better answer than that.
Okay. We have another question from IRC. Are breaking changes permitted across major version number boundaries?
Oh man, that's a good question. JSON schema tools will let you do it. So if you make a new major version, it will let you do it. However, so the answer is yes, that's what we want to do. However, at least in the existing consumer systems, especially on the analytics side of things, there is nothing currently that is taking into account the major version change. So it will still try to use the new major version for the old one. And I think that might be a weakness of the system. Like it might, yeah, I don't know how to solve that problem at the moment. It hasn't been something that we've needed to solve yet, but perhaps it will be in the future. There's been a couple questions about breaking changes, and I think I would ask like why, like what are the breaking changes that we really need to make? What we're talking about here are schema models and breaking downstream consumers. And the only enforcement in the schema world that we're doing really is that you can't change types and you can't remove fields. And because you can't remove fields, that basically also means you can't rename fields, because that's basically a removal and an addition. The only thing you're allowed to do is add new optional fields. And I think for breaking changes, what people mostly want to do is make clean schemas. They want to get rid of old stuff that isn't used anymore in the schemas. But I think most of the time, it's just something that we're going to have to live with. There's going to be old fields in the latest schemas that we may or may not be using so much anymore.
Okay. There's a longer comment in the IRC. I'm going to actually I'll address that there.
Okay.
And then I don't see any questions in the YouTube stream. Just an invitation to folks who are there. You can feel free to ask questions in that spot too. I do have a couple additional questions for you. Can you tell us a little bit more about what will happen with event logging, if it will go away?
Sure. For those who don't know, event logging is our mostly analytics-focused event ingestion system. It is a MediaWiki extension, but it's also a backend Python server component that is consuming events from Kafka. It also keeps its schemas on Wiki, on MediaWiki. There's an actual schema. This is part of the event logging extension is a schema namespace on MediaWiki, so schemas are actually editable on Wiki. Event logging was a big pain for us, and one of the main reasons is that on Wiki schema situation. It's nice for people to be able to edit the schemas, but it does mean then that there's a centralized schema repository that it's difficult to distribute that around to different places that might need it. A developer environment might like need to make a change to a schema to do some development, but they'd have to actually edit the production schema repository to do that. So we're trying to get rid of that. We're doing it in a backwards compatible way. We are migrating the schemas from MediaWiki into the new schema repositories. We're adding some of the required fields like $schema that we need. And we've modified the event logging MediaWiki extension to know how to produce the data so that it will work with the new system, and also to produce it to EventGate rather than the previous event logging backend components. So it should be totally backwards compatible. There's a couple of caveats to that. If you are consuming event data out from Kafka directly yourself, like some teams are doing, perhaps it might only be the performance team that's doing that. There are some format changes for some complicated technical reasons, but we're working with them. But the data, if you're used to just querying data in Hive, in the internal production infrastructure, it'll be backwards compatible there, and it'll continue to flow in there. We're also working with so event logging is a MediaWiki extension. We can produce events from MediaWiki server side or from client side, but events are also produced from other clients as well, like mobile applications. So we're working with those teams to migrate over to producing events in the new format to EventGate as well. So the answer is everything that exists will be backwards compatible. Sometime soon, we're going to make an announcement and say, please, no more schemas in the old system, only do stuff in the new system. And that's going to come up in the next quarter or two.
Awesome, good to know. I have another question for you from IRC. Do you have any thoughts on how to transform event data when you don't control the producers of the events? Maybe the producers are internal code of a web browser or something.
Yes, the right answer for that is to use stream processing. That would be the best way to do it. We don't have that. We don't have an official Wikimedia supported stream processing framework out there. You can definitely consume the events yourself and then reproduce them as a different stream, or just consume them and transform them and do what you have to do. It'd be much nicer if you could use a framework, an existing framework that helps you abstract a lot of the complexities and running that in a distributed way. So probably sometime soon that will be Flink, sometime soon being maybe in the next year, maybe, fingers crossed. That would be the right way to do it. There's a lot of really nice primitives for ingesting, consuming streams, filtering them, modifying them, and re-emitting them to other streams.
Great. And then I just have a couple of notes from the IRC stream as well. Somebody made a comment that we do have an architecture office hour where folks can come and bring questions about domain-driven design and data modeling. And so I will put a link to that. I don't have the link with me right now, but I'll put a link to that on the YouTube channel for folks if they want to look at that as well later. And then I actually had a question for you. You've mentioned the Ben Stafford talk a couple of times, and I was wondering if you have a link to that as well, and I can add that to the channel so that folks can look at that, and I can also share it out for people so that they have that information later.
Let me see if I can find it. Looks like it's a Zoom link. It's on the, I don't know what calendar this is on, but I can paste the Zoom link. Should I put that in? Where should I put it?
Why don't you go ahead and put it in Zoom for me, and then I'll share it onto
Okay, sounds good. Sounds good.
YouTube.
This is the Zoom link. I just got that out of the calendar invite.
Perfect.
Yeah.
Awesome. I'll put this on YouTube for folks in the chat.
Okay. We should check with Grant or whoever is setting this up to make sure it's a public.
Oh, to make sure it's public. Okay.
Yeah.
Yep. All right. Before I do that, then I'll check.
I don't see why it couldn't be though, but yeah.
Okay. Perfect. Yes, and then I'll do a last call for questions. If folks have any more questions, feel free to share on IRC or on the YouTube stream. And then actually one more question. If you have some examples of how we're using Event Platform for production use cases now.
Well, we've been doing events in production for a little while. I gave a talk 2 years ago about it, and we're still, the system that we replaced, the production one, looks pretty similar to this new one. At the time, it was used by ChangeProp in MediaWiki job queue. So MediaWiki is actually emitting events that represent jobs that need to run, and I think ChangeProp is scheduling those to be run by MediaWiki job interface. It's also used, I think, to expire REST-based caches. More recently, the SRE team has used it to also expire and purge Varnish and ATS. I'm not sure if, I guess both of them, I'm not sure, but front-end CDN caches, which is really cool. Previously, they were using a UDP multicast-based system, which was pretty unreliable, and I think this has helped them out a lot. And a really cool, we're using it for, I guess this is, I don't know, does this count for production? We're using it for client-side browser error logging. So when there are errors in the client-side JS, we get some information about that. And a really cool use case that the SRE team is looking to implement is Chrome. I think it's just Chrome and the W3C are pushing forward a browser reporting API that browsers can use to be configured to send information about, say, like network errors that a user might be encountering to an endpoint. So this is different than client-side errors. This is when like a browser is trying to connect to, say, Wikipedia, and for some reason they can't. Maybe there's a link broken in between your browser, your internet connection, and our servers or something like that. The browser itself can be configured to send some data to an endpoint. And the SRE team is looking to use this system to collect that information. I think that's super cool.
Awesome. All right, well, I don't see anything else from the YouTube stream or questions on IRC. I will make a note that we did mention a couple of things in the talk, both architecture office hours and the talk by Ben Stafford. And so we're actually I'm checking right now to find out if those are open to the wider community. And if so, I'll share those links on YouTube. So I will make sure to find that out for folks. Other than that, thank you so much for joining us for this talk, Andrew. It was really interesting. Yeah, and also thank you to Brendan, who does all of the AV for each and every one of these talks as well. So I'll go ahead and put relevant links in the YouTube stream and also on our Wikimedia Tech Talks page. And you can check back next month for our next talk. All right.
Great.
Thanks
everybody. Thanks for coming.
Bye.
Bye.